Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings. This is a weekly meetup that we have for people who are new to Python, and it's really just to help people get started and learn how to use Python. I remember when I first started, I found it a bit daunting just knowing where to start because there's so many different ways. If you'd like to follow along, you can participate in the chat. I'll be watching the YouTube chat, and I'll also be watching the Slack channel. You can see on our meetup page there's instructions on how to join the Slack channel, so you can send an email to skypyproject@gmail.com for an invitation to join the space. But if you can't get onto that now, just enter details into the YouTube chat and add your questions there, and I'll try to respond. Today we're going to be using Google Colab, which is a way of running Python online, so you don't even need to have Python installed on your computer. It's a fantastic way for beginners and even experts to use Python if that's the sort of work that they're doing. Can be used in a Jupyter Notebook, which is an online way of doing Python. If you click on the link here in the meetup, which is also the same link as in the YouTube video, it should open or take you to a new tab that will start in Google Colab. You will need to have a Google account to run this, but this has fired up a Colab notebook for us. We're going to be continuing on from last month. So the first week of every month, we try to go back to absolute beginners, so people who've never seen Python before. So any question you want to ask is fair game, and we'll hope that we can help you. I'd be interested, even if you just want to put on the chat just how much experience you've got, so I can get an idea of how to target the people watching. All right. So the first week is it for absolute beginners, and every other week we do a little bit more advanced. But this one is a follow-on from last month's. So we call it Getting Started 2. We'll be looking at Python dictionaries and also Python functions. However, if you haven't done the March session, then I'm happy to go over anything that is confusing. We're going to be using Jupyter Notebooks, so I'll just recap now how they work. Jupyter Notebooks are made up of cells, and in the cells, so this is a cell here, you can play a bit of code. So you run a little short program and run those snippets of code. So you can see these first few cells have all got some code in them that you can run. There's also these text areas where I describe what we're about to do. You'll see in between them you can add a code cell or add a text cell in there, so you can create new cells and run your own bits of code in them. Now the first thing I suggest you do is copy this to your drive, and that way you can save all the changes that you've made, because this link is one that's to a notebook that's in my area. But if we copy to the drive, it'll create a copy of this meetup. You see it's got copy of meetup 102, and now you can make changes to this and save it to your own drive. So using Jupyter Notebooks, so let's try running a cell. Here's a cell that imports the sys library, which is just one of the Python standard libraries, and prints out what our version is. And this is a way of finding out what version of Python we're currently running. So the very first cell that you run in Colab is a bit slow because Google has to set up a whole bunch of stuff behind the scenes to get you going, but after that it should be a lot faster. So here we can see we're running Python 3.7.10, which is a little bit old, but it'll do for everything that we're doing tonight. So if you were using just normal Python on a command line, then you would use Python -- version or Python 3 -- version to see what version of Python you're running. In Jupyter Notebooks, you can run a few command line things. So for what you would type would be, let's try Python 3 -- version on the command line. From Jupyter Notebooks, if you want to run something on the command line, you have to put an exclamation mark out the front. And then to run it, we can press the play button there, or we can do Control Enter. And that's telling me that it's running Python 3.7.10. So it's the same result, but that's what you'd type if you were doing this Python installed on your own computer. Okay, so let's recap. Last time we talked a bit about data types and storing the data in variables. And there's different sorts of data that we can store. We can store integers, we can store floating point numbers or numbers with decimal points in them. We can store booleans, which is true or false. We can store strings, which are text. And we can store lists, which is a whole bunch of other sorts of data. So, and the list is enclosed in square brackets. And we can even store tuples, and a tuple is just like a list, but it's immutable, which means you can't change it once you've created it, and that's useful in a few things. So if I run that cell, it saves all those values into all these variable names. So these are just names I've made up, my int, my float, my bool. I've just made all those names up, and it stored them. Now if I want to see what's in any one of these variables, I can just type the variable name, and in Jupyter Notebooks the very last line is displayed, the value of that variable is displayed. Now I've put 2 lines here, so you will see that the second last line won't be displayed, but the last line will be displayed. And so let's have a look. I'll run this, and we can see the tuple as showing, but the string isn't, and the tuple is, like I say, it's like a list. We just made the tuple from the list, so it's got the integer value, which was 5, the floating point number 5.0, a boolean, and also a string. And the tuple itself, you can see it's a tuple because it's got parentheses there rather than square brackets. So lists have square brackets, tuples have parentheses. So let me know if I'm going too fast as we go along, because sometimes we get people to these beginner sessions who are the absolute beginners to Python, but they've done a lot of programming before, so they can take this quite quickly. Other times we have people who've never done any programming at all before, so they might find it a bit harder if I'm going at this speed. So let me know, and I can adjust to whoever's watching at the moment. All right. So we've got, I'm going to use print to display results. When you're using Jupyter Notebooks, you don't have to, but as you just saw, my tuple there, I just had to put the variable name, and it showed me what the result was. However, some people may be using this code just using Python rather than IPython, and so they need the print statements for this to work. And if you want to get just a straight Python version of all this code, go to this GitHub address here in the online folder. I'll just open that one and show you where it is. So all these session summaries we put up, and this one hasn't been uploaded yet, but if you look at, there'll be another one here which is pretty good. This number 75 is almost identical, so you can get the code from there and run that on your local machine if you want to try using your own copy of Python. Okay, so when we do printing, we can use format strings, and format strings are just a new thing. They came in Python 3.6, but they are so powerful that if you can use if you know how to use format strings, you won't need to know any of the other sorts of formatting that exist in Python. And the way they work is you create your normal string just by having double quotes around it. There's a normal string with double quotes around it. But to make it a format string, you put an F in front of the double quotes. So in this case, we've got F and then double quotes. And that means that anytime it sees a curly brace like that, anything that's enclosed in curly braces, rather than printing the text my int, it'll actually evaluate the expression. So in this case, it'll look at the variable my int and put the value of my int out in the output. Or that's what it puts it into the string and then prints that string. So here we go. It's printed this my int space 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 colon space and then whatever's the value of the variable in my int, which is the value number 5, and it's printed it out. So we can see here how it prints out the different data types. We've got an integer, a floating point number, which is 5.0, Boolean, which is true, a string, which is this text, even with an included single quote or an apostrophe. The list is displayed with square brackets, and the tuple is displayed with parentheses. There are other forms of format strings. There's other ways of doing printing. So here's this line here is well, that's just printing a straight string, and this is a form of the print statement here with commas. And so you just place the different things with commas between them, and it just puts a space between. So my string will print, and it prints all that, and then it puts something in between. In this case, we've actually told it we want it to separate everything with colons by putting this sep equals colon at the back. So each of these values is separated by a colon, and then we've got true has value 1, and then another colon. And then we've used this form of the format string. So rather than putting an F out the front, we put the curly braces and numbers in there, and then the numbers refer to arguments over here. That's getting a bit more complicated. I'd stick with using format strings myself, but occasionally this format can be useful if you've got one value that needs to be shown several times in the string, for example. All right, so let's recap on, we're using lists and tuples. If you're using the Meetup 75, I used a list for this. This time I decided to use a tuple. So we put a whole bunch of strings into a tuple, enclose them with curly braces, and now I can refer to each element of this tuple by using an index, and the index I can refer to a value in square brackets. So here's an example of square brackets. So there's the variable name numbers, square brackets I. So I is going to be some number between 0 and 20, and by using I as the index, I can print out each of the different strings. So in this case, I'll just run this cell. I've created a loop that iterates each time for each member of the tuple, and it prints out the value of I, and it prints out what's at index I in numbers. And you see we've worked out a way of converting digits to names of numbers. So the digit 0 gets easily converted to the name ZERO, and the digit 1 gets easily converted to the text ONE. So let me know how you're going. If you're having trouble running these cells, it should be quite simple. Like you've got the play button there, and Control Enter is another way of doing it. This demonstrates another part of format strings that are quite powerful. You can actually tweak the format output by putting in a colon and then something after the colon. So here we want to go we want it to be 4 spaces wide, and we want it to be right justified. So we do that by putting in a greater than sign in the number 4 after the colon, and that means that all of these are all 4 spaces wide and they're right justified, and so the ones all line up and the tens all line up. There's a lot of different formats. I don't even know them all, but whenever I want to format something in a particular way, I look up the reference to see how to do it, and generally I'll find something that helps me. Okay, so our challenge today is how can we've worked out a way of converting any number between 0 and 20. How can we convert that into its name in text? And the challenge is, how can we do that for more numbers outside the range 0 to 20? So one way we could do that is we could just add more items onto the end of this tuple. And that would work. And here's an example of it working. So there's our tuple now. It goes 0, 1, 2, 3 all the way up to 21, 22, 23. And so that would now work. So if I tried I equals 22 and printed out, 22 gives me the name 20-2. So that worked well. The problem is it doesn't scale very well, because it if we wanted to convert from 0 to 1,000, we'd have to have a tuple with 1,000 different names in it, which would work, but just by looking it up each one. But we've noticed there's patterns there, so there should be a better way of doing that. Alright, so let's return numbers back to just having the numbers up to 20, and the way we'll do that is we'll slice off the last 3 elements that we've just added to it and put that new value back into numbers. So we're not actually, remember I said before, tuples, you can't change the contents of a tuple, and that's true. If you want to have a new value, you actually have to replace the existing value with the new value. So if you had a list, you could just delete a couple of items from the list, but because you've got a tuple, you have to actually assign that variable with the new value of the tuple. That might be a subtle difference if you're pretty new to this, and if you are, don't worry about it. It's a little bit more advanced concept. Okay, so we're trying to solve the problem of how to print lots of names of numbers. So one thing we could do is we could just store the names of the tens into another tuple, and then we can just concatenate them together. We can take, so for 22, we could take 20 out of here and 2 out of the numbers tuple. So let's have a look at what tens looks like. Yep, there's our tuple. It all saved it nicely. And so how will we do that? So say, for example, we had the number 27. So we've stored that in our variable I, and we want to split that up. We want to know how many ones are in it and how many tens are in it. So we can use modular arithmetic to find out how many ones. So remember, modulo means you divide it by that number and take the remainder. So if we had 27 divided by 10 is 2 remainder 7, then I % 10 will give us the 7, and I minus the 7 will give us the 20. So let's use the print statement where we've just got a comma separating them and see what left and right came out to. So left got calculated as 20 and the right got calculated as 7. So this is quite useful. We can use the 20 here, work out that 20 here links to this name 20 in our list of tens, and 7 links to SEVEN in our numbers. So we use our index here to and in the index we calculate where in this list of 10s we want it to be. So remember, these indexes start at 0, so that's 0, 1, 2, 3. So to get 20 here will be 0, so that'll be 20 divided it by 10, which will give us 2. So then we'll have 2, 3, 4, 5, but we then have to subtract 2 from that, so we've got 0, 1, 2, 3. So I'm going to print these two values on two different lines. So we print 20 and we print 7. So it looks like we're on our way to converting this number in digits to its name in text. So let's try that out. Try this technique out for a whole bunch of numbers. So we'll go 27, 52, 5, 12, and 30. So we'll put them into a loop. And this is the form of a for loop in Python. We have something that we can iterate over, and we have a variable that does the iterating, and we just say for that variable name, and then the word in, and what we're going to iterate over, which is a little bit different format to other languages that you might be used to. So remember to ask me questions if I'm going too quickly for you, and I can put in some more examples until it becomes clear. Okay, so I is 27, 52, 5, 12, 30. So every time it goes through the loop, it prints a new line. And in the line, we print I. Then we print, after we split them up, the number 20 and the number 7. And then we convert those to names using the technique we used there and put a dash between them. So 27 becomes 20-7. That looks good. 52 becomes 50 plus 2, which is 50-2. Also looking good. 5 is 0 plus 5, and our formula calculates that to be 80-5 as the name. So obviously we've got some work to do here. What's going on? Why is this coming up as 85? 12 is coming up as 92, and 30 is coming up as 30. Okay, and the reason it's doing that is because Python can have negative numbers in the index. So if we do this calculation here on 5, that calculates to -2. And when Python sees a negative number in an index, it starts counting back from the end. So 90 is -1, 80 is -2. And that's why here we get 85 because the index is -2, and here we get 92 because the index is -1. All right, so we're going to do the first task. And I've left an empty cell here for you to have a go. And we're going to try to write some code that is going to solve this problem. Now you can either pause the video at this stage and have a go yourself, or you can just watch me solve it. If you pause the video, then when you press play again, maybe play it at 1.5 times speed, so you eventually catch up to the live video, and that way you can continue to ask questions and they're actually relevant to what's currently happening. Alright, so let's use the same code that we know doesn't work, but we're going to throw in some conditional statements. So we're going to check for different conditions, and we're going to have if this condition, we do something, else if another condition, we do that condition, and that, so we'll only run this line here if condition 1 is false and condition 2 is true, and then we can have another else, which is only doing that if condition 1 is false and condition 2 is false. You see the way that Python designates code blocks is all by indentation, and this is unusual for most programming languages, but it makes for very clean looking code. So the general way of doing it is to have 4 spaces, but you can have other numbers of spaces. You just try to be consistent in your code. If you're using Google Colab, I think you might find that the default is 2 spaces. So when you press the tab key, it only moves 2 spaces. You can actually change that in your settings somewhere. In the settings here, I think you can change the number indentation within spaces, so you might have 2 there, so you could change that to 4 if you want to be doing consistent Python with everyone else. Alright, now the things we need to check for in our if statements, we need to check, is the number less than 20, and is the number evenly divisible by 10. So less than 20 will catch 5 and 12, and divisible by 10 will catch 30. So let's try. I'm going to, so in the for loop, once again, everything that's indented to 4 spaces is part of the loop. So I put my if statement in here, and I want to check if I is less than 20. And if it is, I can just print I, comma, I'm not going to do pretty fancy print statements here. And then we'll just look up our tuple of numbers names and print the ith one there. Okay, and then I can do an else. So everything else I want to be in this else. So I could do an else if and an else if, but I think there are some bits of code that I want to run in both of them. So I'll just do an else. And in that case, I'm going to calculate my right and my left. And then I can check if it's evenly divisible by 10. Okay, so if the right number is 0, and the double equal signs is the way I check for equals, then I just want to print, I just want to look up tens. I don't need to do 30, 0, I just want to do 30. So in this case, it'll be the left number divided by 10 minus 2. Else and then I can do the same thing there. And I want to then put in a minus sign, and then I want to put in the right number. So if I was going to do this, if I wanted to use string concatenation, I need to convert it to a string. So let's do that. I'll convert that to a string. Then I'll add in a minus sign or dash, and then I'll do a string of the right value of the numbers. Okay, so 27, 20-7, that worked, 52, 50-2 works, 5 gave me 5, 12 gave me 12, and 30 gave me 30. So this code worked. These string conversions look a bit clumsy compared to what we used to before with format strings, so I'd probably recommend using format strings more often. Let's have a look at the solution. Here's a solution here. This used if, and else. And it did fancy print strings for all of them, so let's just check it works. And it works, and it's a lot more nicely formatted in the output. So that's how you would use the if, else pattern. All right, any questions there? All right, so what we're finding, we have to put this complicated formula in here in the index to be able to get the correct name for the value of tens when we're printing it out. So that's a bit complicated. It would be good if we could just say tens and then in the index we put the value 20 and it would give us 20. So what are the other options we could use? We could try using a sparse tuple so that it just had lots of blanks in there, and then when it got to 20 it had the name 20, and then I'll hold 9 more blanks, and then the 30th one would be 30, and then 9 more blanks, and then 40. But this is where we're going to use the dictionary type that Python has. And the dictionary type is a very powerful type. You see them in other languages, other programming languages. They'll be called something like an associative array, or even a dictionary. They're called. I've seen them called dictionaries in other languages. But the code for defining them in Python is very concise, and so they're a joy to work with in Python compared to other languages. They're a bit like a JavaScript object, so it's pretty similar there, as you've seen in JavaScript object notation, but the Python one can actually let you do a few more things that you can't do in JavaScript objects. So in JavaScript objects, I think the key always has to be a string. But in here we can use a key can be an integer or a string or other types, as we'll see later, and then a value. So this is a bunch of pairs, key value pairs they're called. There's the key, 20 is the key, and then the name TWE and TY is the value. So there's a colon separating the key and the value, and then commas separating each of these pairs. So that's pretty similar to JavaScript object notation. And by doing that, you can then refer to any value within this dictionary just by using the key as the index. So that makes it a lot simpler. So 10s 40 is FORTY. All right, so before we go back to our number name problem, let's have a look at a few of the things that we can do with dictionaries. We could have keys can be strings. So let's have a key of A giving us alpha, B is Bravo, C is Charlie. And then let's print out the whole dictionary. Okay, and you see I've put a \n in there. That's a way of putting a new line in my print. So it's printed on 2 lines. Keys can be string, and here we go, A alpha, B Bravo, C Charlie. All right. Keys can also be other things. They have to be hashable. So to be hashable, it has to be immutable, and has to be capable of creating a hash from it. So basically, if you say immutable, you'll get most of the cases. So here I've used tuples as my keys, and they work fine. Note that the tuples can only work if the data types in the tuple are also immutable. So you can't have a tuple of lists, for example. That would not be a hashable type. So here's an example of trying to use a list, and I've commented it out because I don't like having code in there that breaks my notebook. But if I uncomment that and run it, you'll see I get a type error, and the error is unhashable type list. So because I'm trying to use a list as a key, it won't work. So I'll just make that a comment again and get rid of that error. Now, if you want to add new values into your dictionary, it is immutable. It means that you can make changes to it. So, for example, I can add a new key and value by using these square bracket notation. So, the square brackets, what the new key is and what the new value is. So, let's make D is value of delta and E is value of epsilon. And let's have a look at the dictionary after I've run those 2 lines. And we can see now we've got 5 elements in there, so it's added on to the end. And if I used a label that was already there as one of the keys, it would just overwrite a previous value that was there. The dictionary, so D is a dictionary, has a method on it called update, which means that we can pass in a new dictionary to it, and it will merge that new dictionary and update the existing dictionary with that merging in the new one. So let's have a look at what happens when I merge this dictionary in here. We got Alpha, Bravo, Charlie, Delta all stay the same. E, which was epsilon, now gets changed to echo, and a new item F gets added in, which is Foxtrot. There's a couple of functions that you can use on dictionaries which are useful. If you want to get all the keys, you can use d.keys. If you want to get all the values, use d.values. Or if you want to get all the key value pairs, then you use items. So let's have a look at what they look like. So they're the keys, A, B, C, D, E, F. They're the values, Alpha, Bravo, Charlie, Delta, Echo, Foxtrot. And here are the pairs. A is with Alpha, B is with Bravo, C is with Charlie, D is with Delta, etc. So where are these useful? Mainly when you're wanting to do things like looping. If you want to loop through a dictionary, you can say for K in D. So you put your dictionary here, and that's the same as if you put d.keys. So they're synonymous. You could have either of them there. It will loop through. You can then get the value at that key and print both the key and the value. So you can see why did that not go in the right spot? d.keys gives me the same thing. All right, so what I might do now, I've typed a few things, so I might share this notebook, so you keep using the notebook that you've got, but if you ever miss something that I've typed, then you can use this link to refresh and you'll get the latest version that I've typed. So I'm going to put this on YouTube chat, and I'll put it in Slack as well. I'm not sure whether it's coming up in oh yeah, it's come up in YouTube chat. All right, so we've got our new dictionary of tens. Here they are there. So can we rewrite the solution to task 1, but this time use the dictionary? So let's get our solution for task 1. Redo task 1 using a dictionary. Okay, so there's the solution to task 1, and just here I can get rid of this complicated formula and try running that, and that worked. So that was good. Compare it to the answer. Yep, no difference. So I think that makes the code a lot easier to read. So that's a good case for using dictionaries. All right, expand solution to task 2 to handle numbers up to 999. Test on these values here. All right, so we'll take our code, we'll add in some extra test values. So what do we need to do first? We need to see if there's any hundreds in the value that we're going to convert to text. Now this is starting to get, this is a really good problem actually, because most people understand the problem very well because they could convert. They learnt in school how to convert any one of these numbers. So for example, we want that one to say 100, O-N-E-H-U-N-D-R-E-D. We want this one to say 112. We want this one to say 300. We want this one to say 999. So we know what we're trying to get it to say, but how we solve it is actually quite tricky. So there's a fair amount of logic involved in solving that problem that we do just naturally. So it's a good test for how well you can do this programming. So I really, even if you watch through this whole video, I recommend you go back later and try to do these problems yourself. So don't try to memorize the solution. Just try to work out how you would solve it yourself. So you can come up with a different solution. There's no problem with that. But the thought processes that go with coming up with that solution is where you're going to really learn how to be a programmer. So let's try to we'll work out if there's any hundreds in it. So we'll create a variable called number of hundreds, and we'll use our modular arithmetic as we did before to divide that by 100. Okay, so if that is greater than 100, it was greater than 0, then we want to print out that many hundreds, which is really just well, let's store it in a string, so we'll call it string of hundreds. And we're going to use our list of hundreds, our list of numbers names, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can call that up just using that index. And that's a string, and we'll put 100 and there. Now if it's not greater than 0, we don't want to do anything. So we'll just call that an empty string. All right. And what we might do, then we want to calculate the remainder of all of this. So let's just say we want to subtract any hundreds that we've already dealt with. Hundreds times 100, so that we can just deal with the last two digits of the number. But if number hundreds is 0, then this won't do anything, so that's fine. Okay, and then in our solution, we won't bother doing that. So we're going to have, if I is less than the length of numbers, so I is now a number. Hang on, I'm just going to get rid of this. Yep. And I won't bother trying to get this. So in fact, I won't even print these out because they'll just confuse people. So let's see how we go with that as the code. All right, we've got an error. Tuple index out of range. And yep, I used modular arithmetic. I actually wanted to use integer division there. So 100, that should give me 1. 300 should give me 3. 999 should give me 9. So I'll use integer division. There we go. So these numbers under 100 still work, so that's good. We haven't broken them. Then I'm printing out these are the numbers after I've changed it, so I shouldn't even be printing those out. But we got 100 and 0 for 100, so not great, but close. 112, perfect. 300 and 0, not good. 999, excellent. So how are we going to fix this? We're going to have to put in some more conditionals. So if, and let's just look at the solution and see how it worked it out. So the AND was part of the issue. Sometimes we want the and sometimes we don't. So here we've got 100 and 0, but if there's nothing after there, then we don't want the and. So we'll create this number here. We can show just the hundreds name. If we've got a hundreds name and a remainder equals 0, then we just show the hundreds name. So that'll be like 300. So that'll show there. If the remainder is less than the length of the numbers, then we can just print out exactly the remainder. And in that case, we want the conjunction, which is the word and. So every time we haven't got a remainder of 0 up here, that's we're going to use the word and. So this is the only time we don't need an and that's when there's nothing after it. So that's why that's the only time we don't use the word and, which is our conjunction. And every other time we want and. So that's how we solve the problem when to show and. And then all the rest of these are just the same conditionals as before, but we're using remainder here rather than that I did up here, and that means that we can still print out our I value properly. So you can see there's quite a lot of logic involved in coming up with these names, which is why it's such a great programming problem, and I really recommend having a go at it. I've even thrown 0 in here as one of the options, and that's printed out fine as well. So that would print out in so the conjunction only has a value and when hundreds number is greater than 0. So otherwise the and is not there. So we don't need an and if we haven't got a remainder. We don't need an and if we haven't got a hundreds. So the other times are when we do need the and. Okay. How are we going? So let me know if you're finding this too tricky. Now we have some code which works for numbers from 0 to 999, but we don't want to have to copy 18 lines of code every time we want to use it. So this is where we use Python functions. Now functions can be are great for reusing code, so you define a function and you put that code in there. There's also some built-in functions that come with Python. So to start with looking at functions and how they work, let's play with the built-in ones and see what they do for us, and then we can have a go at writing our own. So functions can do different things. Sometimes you just call a function and it does something for us. So print is an example of a function that does something for us. Print help is another one. License, copyright, these are examples that do things. We don't give it any extra information. It doesn't return any values to us. It just does some sort of task. So if I give print without giving it any information, it will give me a new line, an empty line, which you can see is slightly different from if I just run this, which doesn't have a print command, and that doesn't leave a blank line. So it is actually doing something, and it's just leaving this blank line. Now I could also run help, and help's a really useful one for beginner programmers. It can give you all sorts of things, tell you how to do stuff. You can put in module names, keywords, symbols. You can even create help documentation for your own functions, as we'll see later. Okay, let's stop that one. If you're using Jupyter Notebooks, a better way of doing help is using the question mark. So you could do question mark on print, and that will open up here on the right hand side the help that comes with the print command, for example. So you can do the question mark, I think, either side of the, yep, that looks the same. And you can even do 2 question marks. And what's that going to do? That's the same again. Sometimes they give you slightly different, but that'll do for now, and then you can close these when you're finished with them. Alright, let's have a look at license. here we go. That gives you some details about the Python license. We've also got copyright. I'll tell you some details about how Python is copyrighted. All right, and now some functions return a value. So let's have a look, see if copyright returns any value. So I'll run that, and to get the return value, so the function name is copyright. To call a function, you put the parentheses after it, and then to get any return value, you put it on the right hand side of an equal sign and have a variable there that's going to catch the return value. So it prints out the copyright as we saw before, and then our print statement here says the return value from copyright is none. So it hasn't actually returned anything, it's just returned what's called a none value, which is nothing. It's like null or nil in other languages. Okay, so that's an example of return values. This is an example of passing arguments to a function. So arguments are values of data that you can provide inside the parentheses, and the function will use those values to do what it has to, or to return some value. So in this case, we're going to run the print function. We're going to pass 3 arguments in there with commas between them, and what it's going to do is print each of those arguments separated by a space, all on one line. Okay, here's another example of using the print function. This time we're sending 1 argument. See, we've only got one, we haven't got any commas in there, so it's only 1 argument, but we're using a format string, and so it's another way of achieving a similar result, but with only using one of the arguments of a print function. And so we're going to use these format strings and build it up. So we've got the if, and we've got these curly braces to evaluate expressions within the expression, within the string. And so S1 becomes example, 3 minus 2 becomes 1, and then that's the whole string that got printed as a single argument call of the function print. When you have arguments in a function, you can also you provide the arguments in order, and it will use them in order. If you provide them with names, then they don't even have to be in order. So print can use a couple of named arguments like separator and end, and those you can provide in any order. So you can provide separator and then end, or you can provide end and then separator. And some functions, the arguments only work with positions, some they only work with names, and some can work with either names or positions, but we'll see that later. So let's run this, see how it goes. So there's an example of print. That's just using the position of them to work out the order. The next one is also using positions to work out the order, so there's no named arguments there, only positioned arguments. This one here has got 3 positioned arguments and 2 named arguments. So it prints out the positioned arguments, because that's the way it works with positioned arguments, and then the named ones, it knows that we want to use dash as the separator, so let's put dashes in there. And the end, which is normally a carriage return, a new line, I mean, it's normally a new line, but we're going to put a space there instead. So example of print, it printed to there, and then rather than jumping down to a new line, it left the print statement on that line, so the next print statement continued on the same line with named arguments. So using the underscore separator there, and the end character is going to be less than, new line, less than, new line. So we've got less than, new line, less than, and a new line. All right, let's have a look at some other built-in functions. So we can just call these functions. We don't need to import any libraries to use them. So we're going to use min. So min can take the minimum value of a bunch of values. Yep, and print it out. So let's we can also sum a list of values or some sort of iterable sequence of values. We can find the maximum, like minimum, of values. Once again, those are maximum min are pretty similar. You can see they work with integers, or these are integers and floating point numbers, so they will all be converted to floating point. And this is letters. Yep. Let's run that. Okay, so the minimum value of that is 2.5. The sum is 83.4. The maximum is the lowercase letter c. And you remember from last month, that's because of the way letters use ASCII, or the lowercase later in ASCII than the uppercase. And similarly, the maximum of a list is the same as the maximum of the individual arguments. So let's have a look at help sum. And you can see sum can be a iterable list. So that's out. We've done a tuple. So that's something that's iterable. We can iterate over that. And we can also provide a starting value, which is if we want to sum those values and then add it to the starting value, that's where we could do it. So we could actually put a starting value like that, and that's added 45, and then added all the values in there starting from 45. So because we can provide a starting value, it means we can't do we can't just have a whole bunch of arguments here, because there's only one argument as the starting value, and so if I do that, we'll get an error. So sum expects at most 2 arguments, but it got 3. Alright, so that's where it's useful to look at what the help of sum is. Let's have a look at the help of min. And max, in fact, we'll do max, because we've done an example with max. So max has 2 values. You can have 2 forms. You can have iterable, which is what we've done here with a list, or you can have arg1, arg2, arg, and as many arguments as you like, which was what we've done in this case. So looking up the help on max, we can see that either of those 2 forms are legitimate ways of calling the max function, but the help on sum showed us that we have to provide all the values in an iterable data structure if we want to do a sum of them. Alright, so we're still working on functions. Methods are a type of function. They're attached to classes. We don't really know what a class is at this stage, but the way you call a method is you take an object of that class, so in this case a string, then you do a dot and then the name of the function, which is the method of that class, to run that function on that value. So my string, you remember, was I think beginners Python and machine learning, and we're going to convert that all to uppercase and return the output of that. So let's have a look. Yep, beginners Python and machine learning. So that's how we've taken the string, we've converted it all to uppercase, and that's returned a new string, and then that new string we've printed out in our print statement. Similarly, we could convert it to lowercase, or we can convert it to title case, or we can split it. So split will split something on the space character in words, any white space character. So Bob's Diner gets split into Bob's and Diner. Title looks at every section here that's a word, which is a group of characters together, and makes the first one a capital. So we can see here that that's not really suitable. Bob's Diner become Bob with a capital B, S with a capital S, and then Diner with a capital D. So I'm not sure why they've done it like that, but that's how title works. Alright, so let's start defining our own functions. And the way we do that is we use the def keyword in Python, and we define, and then we provide the function name, and then we give it parentheses, in which case where we can place parameters if we want them. But let's start with a function that takes no parameters, and then we've got a colon for our indented code. And what this code is going to do, it's going to use the datetime standard library to find out what the current time is and print that time out. So that's what our show now function is. We've just defined it by running that. If I hadn't run it, it wouldn't be defined, but it's been defined now. And now I can call it by using the function name show now and putting parentheses after it. So anytime there's parentheses after it, it will try to call it. So there we go. The time is now 2021, April the 6th, 8:30, and so that'll be in UTC time on Google's Colab server. All right, you see I've also put this first line of our function is I've put in a string, and that's a documentation string, so you can actually look that up later and see if you ran help on show now, that'll be the string that it returns. I told you that we're indented. When the indent's finished, that's the end of the definition of the function. So if I had show now in the same cell as define show now, if show now wasn't indented, then this wouldn't be included as part of the function. So that's how Python knows that you've come to the end of the definition of your function. Alright, now we can pass arguments or parameters to the function. So for example, if we want to have a function that returns the degrees Fahrenheit for a value that's in degrees Celsius, we pass in the degrees Celsius, we run this formula on it, times 1.8 plus 32, and that'll give us degrees Fahrenheit and return that value. So it doesn't print anything or do anything, it just it calculates a value and it returns that value, and then we can use the return value however we want. So for example, if I run that cell, and that's now defined, and now I can run this loop over a few values, and that will let's see what it looks like. Prints out a little table that's got Celsius and Fahrenheit headings, and says how much the value is in Celsius, what the value of C is, and then we run this function, degrees Fahrenheit of C, and the return value from that, we don't even store it in a variable, we just run it straight into a format string and format it a particular way with 2 decimal places and using a character width of 10. And so we get this nice right-aligned table showing the degrees in Fahrenheit and the degrees in Celsius. For the people who are advanced, especially those coming from other languages, you can, in Python these days, provide extra information to the function when you're defining it by giving these type hints that you don't see it a lot in Python yet, but it's becoming more and more popular. And by putting these type hints in, I'm saying degrees Celsius is going to come in, I expect it to be a floating point number, and the number that I'm going to calculate is going to be a floating point result. And they're used by IDEs, your integrated development environments. So I like using PyCharm. Even the PyCharm Community Edition is very good. And it will tell me if I try passing a value to this function, it's the wrong type. If I put the type hint there, it will tell me. But it won't stop it from running, so it'll still try to do things in the way that Python likes to do it, which is just take any type and do whatever it can with it. So let's have a go. I'll define degrees Fahrenheit, and I will I'll run this cell down here, which is trying to use complex numbers. So you can use complex numbers in Python just by doing this J notation. So anything 24 plus 5J, that's a complex number, and we pass that to Fahrenheit. So it's not a real number, it's not a floating point number, but so it will still work. It's just if you are doing this in an IDE like PyCharm, it will flag it to you and say, what are you doing setting a complex number to this function? It's really only expecting a float. But anyway, it tried to work it out. It said if if the temperature in degrees Celsius was 24 plus 5J, then in Fahrenheit that's 75.2 plus 9J, where J is the square root of -1. Alright, the other thing about this, you can see the doc string that we've created here, and to have a look at that we can use help on our function that we've created, and that tells us, in fact it's giving us all this information, saying it needs the floats as the inputs. It's going to return a float, and it gives us our doc string. If we want just the doc string, we can even use this in code by using this special double underscore value property of the function, and you'll see these. I won't go into too much detail on them, but in this case you can see that the doc that returns the string. You can see there's new line characters there for where the character returns are, or the new lines are, and that's the full string. Okay, so task 4, convert the code from task 3 into a function and return a string. Alright, so let's have a go at that. So I'll find task 3 solution. So I'm going to define a function. Let's call it a number to text. So it takes in a number, I, and then it converts it to one of these strings. So I use the return command, the return keyword, to return the value, rather than printing it. Oh, and I only want the final value. I don't want all our nice tabular formatted code. Okay, then get rid of my indents because I don't. I've finished my function. Every possible outcome comes with a return. So let's try calling the function. Number to text. I. There we go. So now we're calling the function 27, 52, 5, 12, 30, 100, 112, 300, 999, 0. So that's pretty useful now. Now we've got a function that we can just call whenever we want, rather than having to copy all those lines of code everywhere we need to find the text name of a number. Let's have a look at the solution provided. It looks pretty similar to what I've done. Yep, it's just used string concatenation here instead of format strings. Yep, that's fine. I don't know, there's a lot of difference between the two. And it's got nicer formatting for the output. Okay, expand solution 4 to handle thousands up to 20,999. Okay, so once again, this is going through the old logic of how do you put code together, how do you think in your if statements to control your program flow to make this work. So what have we got? We've got hundreds. So if hundreds is greater than 0, so at the moment we're just assuming hundreds is going to be less than 10. But what would happen? So if hundreds was greater than 10, then we're going to be into the thousands. So let's put some code in there to calculate thousands. And I'm just really copying the code for the hundreds. We don't use an AND. If we said 20,999, the only place we put the AND in is between the 900 and the 99. So I don't need to have another conjunction there. Thousands name equals that. That. And I can put a space in there. And I can put this so the reason for this first line of code here is to know that we don't have to use the conjunction because we haven't got any hundreds or thousands. So let's hundreds name does not equal empty string or thousands name does not equal the empty string, and let's put some parentheses around that because I never know whether and or has precedence. So hundreds name, and then in front of each one of these we're going to put our thousands name. Alright, and then we need to test, and we need to test on these values here. Okay, thousands name reference before assignment, very good, that is exactly right. So I said what the thousands name should be if it's greater than 0, but I didn't say what to do if there was 0 thousands, in which case we want it just be an empty string. And the other thing I need to do, of course, is reduce number by the number of thousands that we've got. All right, so let's have a look at our code, our results. 1,000, 1,000, 1,200 is 1,200. This one, 12,345, that's looking good. 20,999, so we're looking good right up at the limit. 4,020, okay, so we missed out an and, that should be 4,020. And 3,200 should be 3,200. Okay, let's have a look at the solution, see whether they could. I could think of a solution that was going to start to help, but it was not going to cater for all examples. So the solution here is using a string here that we're going to build up as we go through, and that's probably a better way of doing it, because when we get to this line here, we can check if s does not equal an empty string. That means thousands or hundreds are greater than 0, and so that's a much shorter way than having to do that same conditional that I was having to do, which is this one here. And that is when we know that we needed to put the and in, except in the case where the remainder number is 0, in which case we don't have the conjunction. So we've done a solution here in not too many lines. It's looking pretty good. And often if you can get it down to a short number of lines, you're doing pretty well in your function design. But don't bust your gut to get it to a minimal number of lines. Try just to keep it a minimum number of places things are going to go wrong. But sometimes you just do need a fair amount of complexity in your logic. So I'd really recommend having a go at this. We've got it working up to 20,999. Okay. Let's have a look. Task 6. Expand the solution 5 to handle numbers up to billions. Hint, start with expanding the range up to 999,999. All right, so once we get to the thousands, it gets more interesting. With the hundreds, it was only ever going to be 100, 200, 300, 400, up to 900. It was just those 9 different values that we could have as the prefix for 100. But for 1,000, we can go up to 999,000 before we get up to the next value. So what we need is some function that gives us a value between 1 and 999 that we can use as the prefix to the number of thousands that we've got. Now it turns out it's our function itself. Number name is already a function that does that. So we can actually call ourselves in this function, and that's called a recursive function, a function that calls itself. That's common in many computer programming languages, and I'm just showing you that Python can do it too. So we call the function, and we pass it the number of thousands that we want. And so now we can handle numbers all the way up to 999,999. So let's try that out in our test data. So you can see how well this is scaling. With just a couple of tweaks to the code, we're converting our function from handling just a small range of numbers to now we're up to 1 million numbers can be handled by this code, rather than requiring a tuple right at the beginning with a million entries to it. So let's check. 999,999 looks pretty good to me. All right, and then expand the solution to handle numbers up to billions. All right, so we've done up to 1 million. So let's do all the millions. Okay, and we'll test that with 1, 2, 3, 4, 5, 6, 7, 8, 9. So there we go. We're doing 123 million. Oh, I said millions rather than million. $123,456,789. So it's scaling pretty well, but every time we go up to another power, so that's got us up to 1 billion, and I could do another thing for billions as well. But it's starting to get repeated code, and it's starting to notice that there's a bit of a pattern here. And when you see a pattern, that usually means you can shorten your code rather than having to just copy and paste code all the time. So let's have a look at the solution. The solution has actually made a shorter function, but it's used this extra dictionary to handle all the powers. So we've got the 100, the 1,000, the million, the billion, and the trillion, and it's going through them in order. And since Python 3.6, a dictionary is ordered in the order that it was created, so going through the keys, it will go through them in that order. It looks at each power, so it's just taken that bit of repeated code and put it in this loop, and then it just loops over that, recursively calling itself each time. So let's try running that and just see if it works. So this is really an exercise for you to see if you understand how this is working, and even try to write it yourself without peeking at the code, and see if you understand really what's going on. So here we go, we're up in the trillions now, 12 trillion, 345 billion, 678 million, 900, and 1,234. Alright, so that's pretty complicated, but a fantastic exercise for seeing how well you understand the logic and program flow. So really have a go at that. Alright, task 7, define a better function than string.title. So remember before, string.title gave us a capital S in there. So what can we do to make that better? So let's say S equals that string. I'm just going to create a few extra cells here, so just make a few code cells. So remember before we had we looked at some of the methods of strings, and one of the ones we looked at was split. So we can split that string on the spaces, and then for each one of those spaces we can refer to, so let's put that into a list. So I'll say list equals s.split, and then I can say have a look at list 0, which is the first element in the list, and that's Bob's. Alright, so I could convert that to, if I tried converting that to title case, it's still going to give me a capital S, but I could convert it all to lowercase. And now I just want to change the first letter to be uppercase. So we know that list 0 is the first element in the list, and now if I want to fit the first character in that string, I can use indexing on strings as well. And so list 00 is going to be a B, and it's actually a capital B because it started off with a capital B, so that's already correct. And if I look at the second element, which is index 1, it's got a lowercase d, which is the first letter of Diner. So that's the one I want to convert to uppercase. Alright, so you see how I've used Jupyter Notebooks to just play around with what functions are available, see how I'm going to do it. And now I think I've worked out how I'm going to do my function. So let's give it a go. So we're going to find the title case of a string. So the first thing we're going to do is convert it to a list of words. And then we're going to iterate through that list, and each word in the list we're going to convert to uppercase we're going to convert the first character to uppercase and all the other characters to lowercase. Alright, so we'll go for W in list, and well, let's just concatenate them onto a result. So the result will start off with an empty string, and so we'll add on to that empty string the first character in the word, which will be W0, and we're going to convert that to uppercase. And then we'll take the rest of the word, so from 1 onwards, and convert that to lowercase. And then we'll return that result. And actually I want to put a space in between each one. So let's have a look at title of Bob's Diner. Let's make it a bit obscure. And that worked pretty well. So we've got Bob's Diner, and it's converted up in lowercase, the right characters. Okay, so look at the solution. We did the split just like we did, so it takes in a sentence, splits it, then capitalized words. It's created a new list using list comprehension. So for more advanced users, this is how in one line you can replace a couple of lines up there. And what you do is you, in the square brackets, which is your list, you put in a loop here for W in words rather than put the for W in list out here, and then in front of that you put what you're going to calculate. So it's really the same code, it's just rearranged to make that list. And then although I concatenated it all into a string, this has made it into a list. So this will be slightly faster, and it uses the join function to join all the capitalized words. So it takes every member of the list, puts them together with a space in between, so that's what the join character is. So let's check that that one works. Bob's Diner, that works as well. So let's just check what would happen if I had a one character word in there. I'll probably get an index there. Oh no, that worked. Oh, of course, so one colon, that returns an empty string if there's only one character in the string. So that worked. All right, when we're defining functions, we sometimes want to give a default value to one of the parameters. So it means that it becomes an optional parameter. Someone calling the function can provide that parameter, or they can just rely on the default value. So remember, if you looked at the help on string.split, the default character for separator was none, and the default value for maximum split was -1. And for none, that means split according to any white space. So that spaces, tabs, carriage returns, new lines. Maximum split says the maximum number of splits you want to do, but -1 means no limit. How are we going here? Running a bit low on time, so I'll just race through this. Rewrite solution 7 to have a named argument separator with a default value none, which gets passed through to split. And this is how you do that. In your parameters, you say separator equals, and then you put the default value there. And I just warn you, don't put mutable types as your default value. Don't put lists or dictionaries as your default value. But it's a bit too complicated for me to explain why. But just use immutable only for default values. Words, sentence split. So we can pass through that named character to the sentence dot split when we call that function, and so it will work on that as well. So that we can now split on underscore, and so it's capitalized every letter that's after an underscore. So it's capitalized the I and the E and the first character, which is the B. if you have all the arguments in an iterable list, you can unpack. Okay, so I'm now getting into a bit more advanced stuff, so absolute beginners really don't pay much attention, but for people who are new to Python but have experienced in other languages, you sometimes may see things like a function being called with asterisk.listargs. So what it does, that when you're calling a function with an asterisk, it means unpack the values of this list and provide them as separate arguments. And so you can see here I've got a list of arguments being the split of all that. I split them on white space being these tab characters. So I've got my tab separated value here. My list of args is /t and 4. Oh, actually, so that's what I'm passing through to split it. And the result, because those are both in one variable, but by passing them through to star list args, it splits them up into separate values, separate parameters in a positioned order, and then calls the function. So you can see it's only done 4 splits because we've got a 4 there, but it split them all on the tab character, which is the /t. And this one didn't get split because that's more than 4. There's another example. So you can see the difference when you print. If you put the star in there, it splits it up into different values. If you don't put the star in there, it just prints the whole tuple as one value with no separator between them. Similarly, when you're defining your functions, you can use the star here to pack the values into an argument. So when you're calling, it unpacks. When you're defining, it packs. And that way it looks the same both ways. So if we run unnamed, so this is, I call it unnamed because all the arguments are unnamed. You can't use a named argument in there, it will fail because we've used this notation. And that shows how it works. You can also pack and unpack with named arguments, and that uses dictionaries to do that. And that also uses the double asterisk or double star for packing and unpacking. So there's for unpacking here, double star, and this is packing, double star. So just work through those, or you can ask me questions. I'm going to finish up now. In Python 3.8 later, I can't demonstrate this because we're only Python 3.7. This is how you would define your functions to only allow named arguments, or only, which is by doing the star in the front. That only allows named arguments, not unnamed arguments. And if you put a slash here, that means only allow unnamed arguments, so position only. Okay, so that's the end of the session tonight. Hope you enjoyed it. Next week should be Arun. He'll be doing some more machine learning. If you like the session, please click on the like, and also I'm looking for subscribers. If I get enough subscribers, I can make my own channel name. I'm going to quit the video here if it so you won't be able to do any more chat on YouTube, but I'll keep listening to Learning to Code on Slack. And so if you've got any questions, feel free to ask on Slack. Thank you for listening.